Here we are. Okay. All right.
We have Book Davies on, Cameron Gillis. Mick Whitaker is with us. Mike Wiesner is on. Hope everyone has had a chance to see and photograph Nova V1405 in Cassiopeia. I could not, Mike. I was actually out with my telescope. I did make an image of the moon, but that's about all I could get. There was so much haze up there. Book Davies said he just ordered a sweet set of 462 series eyepieces. Thank you, Book. That's great. Martin Eastburn says, howdy from East Texas. James, the astrophotographer, is on with us. It's great. Pekka, hello, everybody from Sweden, Stockholm. Cameron says he will vouch that he'll love the eyepieces. Thank you, Cameron. That's nice.
I can vouch for that too.
Yeah. I could say
wonderful.
something, but it sounds very self-serving, doesn't it? So.
Well, no, I actually, and Scott, you know this, I chose Explore equipment for my Astronomy for Educators program at the University of Arkansas.
Yeah, I do.
I could have gone to anybody, but
true.
I picked Explore equipment, and I love it, and it impresses every single time.
Awesome.
The most common response when my students come out the first night out to the observatory and ranch is they put their eye to the eyepiece, and the common response is, wow.
Hello, everybody. This is Scott Roberts from Explore Scientific, and this is our number 2, the second program of How Do You Know with Dr. Daniel Barth. And so today he's a lot more casual, which is nice.
I am.
That's right. Somebody told him to lose the tie. I don't know who that was, but anyways, I was, I was putting up the information for your that you can download. If you go to explorescientific.com/how do you know, you'll go to the page where you can see where you can go and download this teaching curriculum that Daniel makes that you can use in classrooms. It can be used for homeschooling. You know, he is the STEM leader for the University of Arkansas, and all of his teaching materials are up to science standards. And you know, so you can feel rest assured that you're giving the best information. You know, you follow along, Dan, you'll be teaching like a pro. So, this particular program is, you know, how do lunar phases work? And so I took the liberty, and I'm sure you're going to answer some of these as we go along. But I took the liberty to go to the Lunar and Planetary Institute. Okay.
Okay.
They have a page devoted to this because it's so important. Okay. Moon phases, misconceptions, and educational research. So some of the common ones, you know, and I don't expect you to answer it right off the top here, but some common misconceptions is that the moon can only be seen at night. Okay. Another one is the moon makes its own light instead of reflecting sunlight. Okay. Another one is moon's phases are caused by the Earth's shadow, you know, eating up.
Yes.
Right? Okay. In fact, I took a photograph of the quarter phase moon over the weekend, and I sent it to a friend of mine, and he thought it was due to an eclipse. Okay. Another one is, I don't know how, this is a stretch. The moon's phases are caused by clouds. Okay.
I don't know how that works.
I don't know how that works either. Okay, the moon's phases are caused by Earth's rotation on its axis. Okay.
No, sorry.
Wrong. The moon's phases are caused by the moon's rotation on its axis, not the Earth's. Okay. Maybe not. Okay, and the moon takes 1 day to orbit the Earth is another one. 1 day. And then another one here is the moon orbits the sun instead of the Earth. Wah, wah, wah. Okay. Dr. Dan, we need help here.
I guess so.
Set them straight. Okay.
I guess so. And this is all kind of scary, Scott. It really is kind of scary.
Apparently, people could not hear me. Let's see if that helps. Does that help everybody?
You're a lot better now. I'm looking for, okay. I had a full page. I had a full page view of the show, and now it's not there, but you're here and I'm here.
So once again, I'll go through the common misconceptions. The moon can only be seen at night. The moon makes its own light. The moon's phases are caused by the Earth's shadow. The moon's phases are caused by clouds. Phases are caused by Earth's rotation on its axis. No, right. Phases are caused by the moon's rotation on its axis. No, the moon takes 1 day to orbit the Earth. And the last one out of that list from the Lunar and Planetary Institute, this is a very serious organization, Okay, the moon orbits the sun instead of the earth. So, yeah, okay. Before your head explodes, Daniel, we'll let you get started with your program.
Yeah. This, I've lost your audio again, Scott. I don't know if I'm having.
Oh, hold on. How about now?
That's better. That's
Okay.
better.
God, technical problem. Sorry, guys.
That's okay. You're kind of going in and out.
Okay.
All right. Anyway, welcome everybody. And is that better?
It's better for me.
Okay. I'm glad. I'm getting. I'm having odd things going on here. I'm not seeing myself live, but that's all right. I never see myself when I run the classroom anyway, so that'll be okay. I'd like to welcome everybody and thank you. It's great to be back with everybody, and I want to reach out today, particularly not just to teachers, but to our friends who do astronomy outreach. Scott was telling about misconceptions for the moon, and I've been doing a lot of communicating with teachers and people who do outreach over Facebook and other platforms. One of the things I've seen is teachers say, "Oh, I've got this great thing for teaching how the moon phase work. We get a big piece of cardboard and we cut a hole in the middle and we glue eight moons around it. And then as we rotate, we put this kid's head in the hole. And then as we rotate it, they get to see the different phase changes." Or they just hold the cardboard still and the child spins. I don't know, it sounds like The Exorcist to me. And I said, "But how many moons do they think there are?" And I had a teacher said, "But there's one. But how many is there in your demonstration?" "Oh, well, there's 8, of course." I said, "Are there only 8 phases?" And she said, "Well, blah, 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 blah." And I said, "No, really, I'm not trying to upset you or give you a hard time. I'm just trying to tell you that it's easy to teach misconceptions. For those of us who do astronomy outreach, it's the same way." And one of the real hopes I have for this program is that those of us, and there are a lot of us who do astronomy outreach, and frankly, Scott, you know this, everyone who owns a telescope by default does astronomy outreach, because as soon as you set it up, if it's anywhere anyone can see it, they walk up to you, "Wow, is that a telescope?" "Why, yes, it is."
Yeah.
And then you're suddenly Carl Sagan. And it's, "How does this work? Do you know about black holes? Can you tell me about quantum wave theory? Are there really solitons?" And somebody says, "No, those are aliens." And somebody says, "No, it's a particle. It's a wave." And somehow you're expected to be the expert.
Yes.
And I don't have any problem with this. I think it's kind of cool. But on the other hand, when we're looking at this and people come up to us and say, "Well, what about this? What about that?" It's really nice for those of us who own astronomy equipment to be able to be active outreach people, to have something to say and something to show. For many of us who go out and set up equipment at night in public places, the Sugar Creek astronomers, I'm sure some of you are on here, the NWA space folks are around, and there's many, many clubs, and they set up regularly. And of course, if you're setting up telescopes in public, you don't want to do that in the dark. So that's when you have usually an outreach person. "Oh, everybody come here and we're going to talk about what we're going to see tonight."
Yeah.
One of the interesting things, you want to do a good job doing outreach. You want to do a good job doing teaching. You want to present things accurately, and you want to keep people from having misconceptions, because that's really terrible to have misconceptions and to teach them. You don't want to do that. So tonight we're going to take some time and we're going to learn how to make a model of the Earth-Moon system that will show you how phases really work. And like so much that I do, this is based on the Astronomy for Educators program. I taught astronomy for 36 years in California, and I came here and I they said when I got hired at the U of A, well, what do you want to do? You're going to be a professor at the U of A. You have to have a mission. What do you want to do? And I said, well, that's easy. I want to change the way people teach science forever. And I want to particularly make astronomy a top tier science in the state of Arkansas. And I got some snickers and I got some eye rolls. But 7 years later, people aren't laughing anymore because we've accomplished a lot of those goals. We've made astronomy a top tier science. And astronomy, it's experiencing a wave. I get emails and messages from people every day. Hi, I'm teaching astronomy for the first time. It's in our state standards now. Can you help me? And the answer is yes. And I tell my young students, my student teachers, the same thing. You already know enough astronomy to teach astronomy. You don't know how the ideas fit together, and you're probably not a skilled educator yet, but we can help you with both things. And certainly for those of us who do astronomy, we absolutely know enough astronomy to teach astronomy. The question is, how do we teach it effectively? How do we teach it inexpensively? And the expense part is important. If you take a look at one of these crazy models, you've seen them, Scott. Model, it has the sun in the middle, and then there's a little earth on a wire, and there's a little gear, and you rotate the earth around, and the moon spins. Those things cost $1,000 or more. They're hideously expensive.
They are cool.
They are cool. They're awesome. But on the other hand, my model costs about 50 cents a student, and each student can have their own, and they're so cheap you can have the kids take them home when they're done. So this is really, it's absolutely fun. I want to know, Scott, is everyone able to hear me and hear you?
I think so.
Okay, because I'm still having a bit of an issue.
In the audience, maybe, are you hearing Dr. Barth okay?
I'm hoping everyone is.
You're coming across loud and clear.
Okay, that's
I was the
terrific.
problem.
Okay, so
The problem.
this is great. Let's get started, and I'll just have you know that for, I'm new at this, for whatever reason, I'm not seeing questions right now. So if you have questions, Scott, I'll ask you to relay them to me. And I'm putting on the live feed, but there seems to be a slight delay, and that's okay.
Seeing questions right now.
Oh,
So
I'm getting that. I'm going
questions?
to, oh my gosh. I'm going to turn off the live feed because, oh my gosh, then I get,
Yeah, if you just turn down. If you just turn down.
Okay.
Okay. Can you guys hear me now?
Questions? Oh,
Jeff Wise?
Okay. I'm assuming that I'm okay on audio.
A bit quiet.
A bit quiet. Okay. I will try to speak nice and clear and loud. And for right now, let's go ahead and take a look at what equipment we need for today. So I have a box of ping pong balls, and I have some black spray paint. Those, some of us, spray paint, we don't like it. That's okay. You can use black acrylic tempera, like the kind of finger paints they use in elementary school. That's fine. You can use a Sharpie marker, anything that will color black, and actually we'll find out there are alternatives. You don't even need to do that. I have some blue painter's tape, and basically, I have a couple of caps from a Gatorade bottle, and that's all we've got for today. Some construction paper and some other things, but that's all we need. So what we're going to start with, and I'm going to see if I can switch my camera. I've kind of lost my live Zoom feed, so I'm having problems finding my. Can I do that? There we go. Now I'm back. Oh boy, this is much better. Okay, I'm going to go ahead and switch to my desk cam so you can see my hands here. This worked fairly well last week. So I'm going to go ahead and switch over to my USB camera. There you go. And now you're seeing my desk cam, and here we are. So what I'm going to do is I'm going to take a look at a ping pong ball, and I don't think this shows up very well on camera, but basically what we're going to do, every ping pong ball has an equator, and you can find the equator, and I'm taking a piece of painter's tape, and I'm cheating a little bit because I cut this beforehand to size. And I'm just going to carefully, and I'm hoping you're seeing all this, I'm going to wrap it around the ping pong ball, and I'm going to get it to where it comes. There we go. And we now have the ping pong ball wrapped in painter's tape. So one hemisphere is exposed. You'll notice that I've cleverly put the logo on top here. Now, what I would normally do is I would take a pencil or something, and I just make myself a little stick like this, and then I would take my black spray paint and I would spray paint half of this ping pong ball. Obviously, I'm not going to do that on my desk live on the air. We would do this outside if we were working with students. The other thing you can do if you're wanting to do this, and I know some clubs like to do this sort of thing, Scott, they want to have an activity for people who come up. You can take, and it takes a little patience, but you can go ahead and wrap 25 or 30 ping pong balls, put them in the bottom of a cardboard box, and just spray into the box. And you will end up with 30 ping pong balls that look just like this.
Nice.
They are very nicely flat black on one side and white on the other. And this is what we're going to use for making our little planetary models today. So far, so good. And you can see our equipment costs little or nothing. Now, we have a black marker here, and we have our moon. And basically now I'm going to start creating. And you'll forgive me because I'm working kind of sideways here, so I'm hoping this is going to work okay. And I'm going to go ahead and I'm going to start to mark out some Maria. And I'm going to make a little one down here, and I'm going to make a bigger one over here. And I'm doing this very, very kind of quick and dirty. And I've made a couple of Marias here, and I've shaded them in nicely. And different lava compositions. Some of them are darker than others. Those of you who've taken photographs of the moon, you know there's more color than it appears. There's some green, there's some blue. I'm going to draw some craters here, and I'm going to go ahead and put a ray system. We know that craters with rays are fairly new craters. They're only a few tens of millions of years old. The moon's surface is very unchanging. And then I'm going to go ahead and I'm going to put some other craters, and I'm going to put some features here. And basically, this isn't art. That's something that people get stressed about all the time. Oh my gosh, I'm not good at art. And what if my little ping pong moon looks terrible? And of course, Scott, you know, and I know it doesn't matter at all.
That's true.
Every moon
that you can't.
There's what are they estimating now? Over 1 trillion planets in our galaxy. Probably half of them have moons. And phases on all of these planetary systems work exactly the same. Yeah. And it won't matter a bit. It's just for decoration's sake. So we've got this one made. I'm going to set that aside. I've got another ping pong ball prepared here. And this time we're going to go ahead and we're going to make a planet. Now, some of the planets my students have created for me are just fabulous.
Yeah.
There's an Earth, and you can see the Rocky Mountains, and you can see the Atlantic and the Pacific. You can see here's a Mars, and it has, I think this one has the Great Maria Valley and the little swirl features as the North Pole starts shrinking. So some of these my students have made for me are truly, truly works of art. On the other hand, here's of course I did. Here's another one, and you can see, oh, this one is orange and purple and blue. And so the art portion of it makes no difference. So I'm going to go ahead and I'm going to get some colored markers out here. Let's clear these things away so they don't distract. And I'm just going to start out. And I'm going to start out with my black marker. And I'm going to outline a little area around the top. And this is going to be my polar cap. And now I can go ahead and let's put several continents on here. Let's have one come down. Let's make a major peninsula like this. And here we go. And let's make another continent in the southern hemisphere. And let's go ahead. And of course, those of you who are into plate tectonics, and we can make a little archipelago here. So let's make a series of an island chain, perhaps, going down this way. And then we can go ahead and let's add some green. And again, I'm just shading and I'm having fun. And my islands, yes, lush, tropical, there we go. Let's go ahead and add some greenery. Let's add a green belt toward the north. And maybe there's a desert. So let's go ahead and add an equatorial desert belt here. Here's some orange shading. And maybe there's a desert belt down in this subtropical island here. And there we go. And we can go ahead and with a blue marker, we can go ahead and shade the rest. And again, sometimes I've seen children and they have wonderful patience. And some of my students have said, well, but there should be lighter blue near the seashore. And I'm like, okay. And some people get very detailed.
Yes.
I will tell you, for those teachers and parents in the group, it's important to stress this isn't art. It doesn't have to be a beautiful and perfect model of our lovely planet Earth. That's not necessary. And maybe we can humor my students. Do I have a light blue? I do have a light blue. Let's put some light blue. I feel like, who's that famous fellow who did art on TV? We'll splash a little color here and we'll make a painting. And here we go. And I've got some lighter blue.
Yeah.
There we are.
I think
And we have a lovely planet.
Yeah.
And is it really lovely in the sense of art? No, it's not. Does it matter? Not a bit of it. It doesn't matter at all. Because I tell my young teachers, and I'm going to tell my outreach people here right now, I'm going to switch my camera for a moment. I'm going to switch back again so I can talk to you face to face. Here we are. There. That's maybe not as much art as my planet models, but there you go. What I tell my outreach people, and I tell my young teachers all the time, it doesn't matter if it's beautiful. It really doesn't. And when people say, but my kids tried this and they were upset because they tried to make a model that had Australia and whatever on it, and it didn't look the right shape. And I say, you know what? Tell your kids, if you're doing this as an outreach, tell the people there, just make some continents, make some ocean, make some little white part near the top for polar caps, or maybe you're going to make a desert planet that's all orange. It's fine. And tell children to make up a name for your planet. Go ahead and make up names for continents, make up a story about it, who lives there, what kind of animals and plants are there. And they can have a great time. This doesn't need to be, many of my young college students get stressed. What if it doesn't look good? And of course, it's not about the looks, because essentially all planets are basically spherical. If they're big enough to be a planet by name, they're spherical in nature, gravity and all of that. But essentially, this doesn't matter. And this one's glued onto a soda bottle cap. The one thing I have found doing this, Scott, is that in fact, the stuff they make ping pong balls out of is some of the most slippery Teflon-like substances you can imagine. Super glue doesn't hold well. I guess the silicone caulk type glues hold fairly well, but they take a day. They take a day to dry. So I found a reasonable compromise. I use construction adhesive.
Huh.
And I take construction adhesive and I take my my basic Gatorade cap here, and here's a blob of construction adhesive, and I want to cap that carefully so I don't get it all over my desk. And then I just take my my planet, and I want to make sure, the one thing I want to make sure is when I glue this, I do want to make sure that my terminator, my line between light and dark, is straight up and down. And this is important for our activity. And people will point out quite rightly, well, the Earth is tilted at a 23-degree. Yes, indeed, that's true. But what we know about scientific models is that all of them lie. There is no scientific model that you can build, that you can afford, that will show all the features, no matter what you do. And you could look at some really expensive orrery type planetarium and say, oh, there's no plate tectonics on Earth. There's always a feature that's missing. This is designed to show how phases work, and it works best when the line between light and dark is straight up and down. So I'll just caution that, and I'm going to set this aside to dry. And for tonight, we'll go ahead and we'll use our little, this is one that I did in class, or one of my students did, and it's not great art, but it works just fine for what we're doing. Now, the other interesting thing, and it comes down to what you want to do. Some folks may want to take a third ping pong ball and make a yellow one for the sun.
Okay.
The other interesting thing is that some people may want to take a ping pong ball model. Let me see if I have one here. I do. What's nice, instead of mounting onto a bottle cap, which is certainly very inexpensive, this one's mounted on a poker chip. And what I've done is I've super glued a little neodymium magnet here. What's nice is if you're out doing outreach, you can have a little whiteboard on an easel. If you're a teacher, you've got a whiteboard in the classroom, and these will just click and stick onto your whiteboard. And you can say, okay, everybody, set yours up to look like this. And it makes it a very nice, of course, teachers, parents, just going to tell you, little powerful magnets are not toys. You don't let children have access to them. You make sure these things are super glued and that they're in, because we've all heard awful stories about kids swallowing magnets, and that's really, really bad. Google it up. It's awful. So if you're going to use this kind of thing with a poker chip, or you could do it on you could glue it onto a quarter or a penny, it wouldn't matter. Anything flat. Obviously, the empty shape of a plastic bottle cap wouldn't let you use a magnet, but this lets you use a magnet. You can put it on a whiteboard. Makes really fantastic model. Now, what we've gone ahead and we've made our model, and now it's time, with a model of the moon and a model of the Earth, to see how this works. I actually had an interesting conversation with a teacher who claimed, this person claimed they had been teaching science for many decades. And they looked at my model and they said, it doesn't work. And I said, well, yes, it does. Well, it can't possibly show all the phases. Well, actually it does. Well, look at it. It's just wrong. And I said, you know, I'm not asking you to take my word for it. This isn't a lesson in I'm speaking, so believe me. Build the thing out of a couple of ping pong balls and try it yourself. It does work. The interesting thing, there are three things we need to make lunar phases, Scott. One is the sun as a single candle. We've got the sun as a single candle. And one thing to think about when you look at this model is the face of your planet that's illuminated, that's the day side, always has to face the sun. If you have your model like this and it's night on the side that faces the sun, your model isn't going to work, and it's not correct. So you keep the illuminated side pointing towards the sun. So we need the sun as a single candle. No, somebody asked me on an email, we are not going to go into how phases look in multiple star systems. I would love to do that as an experiment sometime, but
Not enough time.
that would be a head scratcher. I would have to get some actual candles and set them up. I might try that sometime. It would be a fun experiment, but right now we're going to keep it simple. One planet, one moon. There we go.
Okay.
You could easily do, what if you have multiple moons? Because the moon's phase is dependent not on where the moon is, it's dependent on the moon's position in orbit around the planet. So you could have, if on Mars, for instance, you have two moons, they're not very big. But if you were looking at them with a telescope, you would see the phases were different. And I believe it's Phobos, which goes around in something silly like 9 hours. So it crosses the sky several times a day. Phobos, you would be able to watch it if you could track it with a right system. I'm sure you could. As the moon went around Mars, you'd be able to watch the phase change in real time, and it would be very quick. And that would be fascinating. But right now we're keeping things simple. So we've got one planet, we're calling it Earth. We've got one moon, we're calling it Moon. And we're going to see how the phases work. So we've got, first of all, the sun is a single candle. The second thing that's important is the moon's position in orbit around the Earth. Because it is the moon's position in orbit around the Earth that creates the phases. The third thing, and this is one that really puzzles people when they look at my model. When you set up a couple of, here's an Earth, here's a moon, and you set it up on a table and you're looking at it, think about, relative to the model, where is your eye? Your eye would be several million miles out in space. You would be millions of miles away, and you're looking at it. And indeed, from that godlike perspective, and we'll see this in a minute when we set the model up on the table, from that, high frontier perspective, you would see the Earth and Moon half lit all the time. You would see no phases at all. If you were several million miles above the Earth's North Pole, you would never see phases.
Bummer.
The third thing that's required to see phases is you have to have a privileged point of observation from the center of the moon's orbit. That's on the surface of the Earth. And when we set up the model, and this is exactly what the teacher was arguing with me about, saying it doesn't work. And I said, well, the problem is your eye is way out in space. He's like, what do you mean? I'm sitting here in front of my desk.
No, my eye's right here.
My eye's right here. So we're going to show you, and it's important. And the nice thing is with children, you can actually set this up so that indeed they will be able to put their eye right down on top of planet Earth. I'm going to use my simulacrum here, my little, this is me. So it's me, it's you, it's everybody. We're going to show you how that works. So let's see how we set up the rest of the model. I'm going to switch back now to my desk cam and show you what we're going to do to continue with this model. So here we are. There's our moon. I'm going to take a piece of construction paper and I'm going to draw a nice circle. Now, the way I did this, I don't draw that well, and I've tried. God bless you. If you can use a drawing compass, oh boy, you're the best. My hat's off. I cheated.
Oh, that's how you did it.
I cheated. I took an old clock, and this is actually a garage sale clock. It doesn't work. And all I did is I took my marker and shroop around it, and I did the positions. I marked the hour positions on 1/2, 12, 1, 2, 3, 4, 5, 6, and then I did 9 o'clock. This is a cheat, Scott. It's to make the model look much better than it actually is. And I started out, and what's nice is I start out and I draw the 12 to 6 line. Boom, there it is. And then I come across and I draw the 3 to 9 line. Boom, there it is. Now I have a center. Why did I not draw all the others? Because now I'm just going to draw each of my lines right through the center. And since they all go through the same center, are my angles all perfect? Probably not. I'm sure they wouldn't stand a great deal of inspection. But when I use this trick, then I find out that if I've handled my ruler properly, there we go, all the lines come through the same center and I get a very nice, neat drawing. Now, this is splitting up the circle into 12 pieces. The traditional way to draw the phases of the moon is we do 8. And whoever decided there were 8 phases, right? Whoever decided there were 8. Why not 12? Why not 50? We'll see why this 12 makes sense. The next thing we're going to do, and again, I'm going to cheat here. The next thing we're going to do is we're going to take a Gatorade cap and I'm going to go ahead and plunk down and I'm going to trace out. Boom, there we go. And now we have a circle for each position of the moon. Okay, well, let's draw an arrow. And I want to make sure what side I'm on. I guess we're seeing this side better. I'm going to draw an arrow over here. And I'm going to say, this is to the sun. And pardon me if I'm not drawing that well, but I'm writing sideways, which is always fun. My Earth plop down, and of course I'm going to rotate it so the daytime side is to the direction of the sun. Here's my moon.
Oh, that's cool.
And let's start it right here. Now, the trick is to see the phase, and right now we're looking at it, Scott, like we would if we were standing above it. But the trick is, I hope this doesn't scare anybody. You need to put your eyeball right down here. You need to basically, you need to be looking from this position, right? You need to, if you're a child doing this, you can go ahead and put your head right down on the surface and you can look out. If you're doing this with your phone camera, you can set your camera right here behind the Earth. And if I go ahead and set this up and take a picture and I raise it up and I'll focus in on the moon. And when I take my picture, kapow, and what do I get? I'm not sure if you can see this or not, but what I get is a lovely photo of the new moon.
Looks good.
Now, what I'm going to do is I'm going to go ahead and say, well, all right, we see that it's a new moon. So I'm going to go in here and I'm just going to shade this whole thing in completely 100%. And again, great art. No, but now I see that this position is new. And I can go ahead and I can write on here and I can label the diagram. And here's my phase. This one is new. Well, if we're looking down from above the North Pole, the moon proceeds anti-clockwise. Because if you think about this, if this is a person, you know, lying on their back at the equator, well, what happens? North is above your head, right? You're lying on your back with your head facing north. Then basically, if you're doing that, you're facing north. On your left is east and on your right is west. And so, and people are immediately going to say, but wait, you have the moon moving eastward around the Earth. And in fact, it does. We're going to do another show on this, Scott, on the actual motion of the moon and how to track it. But in fact, if you watch the moon for a month, you'll see that it's moving eastward across the sky. And yes, we go out at night. You went out the other night to look at the moon. So did I. And we say, oh, but the moon is setting in the west. But if you look at its position in the sky, it's farther east every day. So we're going to move this anti-clockwise, friends, counterclockwise if you prefer. One of my friends from Britain said, Well, be sure you say anti-clockwise and not counterclockwise like a bloody yank. So for our friends in Britain, anti-clockwise it is. In any case, if we go ahead and we look again, and now we're looking this way, and we're seeing the moon, and we're seeing now the first phase. And if you think about it, the Earth is rotating this way. So if we're rotating around, when can we first see this? Well, we can first see this just at sunset. We can look over the limb of the Earth and see this, but it's going to go away pretty quickly because the Earth is going to carry us around behind, and so we won't be able to see it anymore. So this moon is actually visible in the nighttime sky. And when we go ahead and we take a look at this, and again, we're very careful to make sure we've got the sides lined up. If we go ahead and we take another picture, and here we go. If we take another picture and I'm looking at it and making sure it's focused on the moon, and there it is. Get my camera and I go bam, and I get the picture. And if I take a look at that, and here it is for our audience, and we see that we have this lovely little fingernail crescent.
Oh, very nice.
Okay, so we go, oh, well, I have a fingernail crescent. I can go ahead and say, oh, well, I have a fingernail crescent. And so I'm going to make sure we're going to draw the terminator, Scott, which is the line, the boundary between bright and dark. And I'm always going to start at the top and bottom of my diagram here. And I'm going to go ahead and I'm going to draw a nice terminator crescent that will stay bright. And then I can shade all the rest. And as we continue to go around, now we should be seeing something that is between, that's a little thicker crescent. And if we go back and we take another photo and we look, and here it is, make sure it's focused properly. We take another photo, and there we go for the audience. You can see this.
Awesome.
Now we're not at quarter phase yet, but we've got a crescent. Of course, you can see where we're going here. As we move around, we see, now we're going to see, oh, we've got an illuminated moon that's half lit. From the perspective of someone looking here, looking out, the moon is now half lit. And people say, well, is this model that good? Can you explain to me why we're seeing the waxing moon in the evening sky? Think about someone here, right? And this is to the sun. So this is noon. And as they're turning around, as the sky gets dark, they're seeing the moon straight up in the sky. And yes, as they continue around, remember it's the Earth's rotation which gives us our apparent view of the moon. As we hit midnight here, the moon sets, it's at our horizon, and after midnight, we no longer see this moon. So this model now shows us why we're seeing the moon, the waxing moon, every evening. As soon as we make that turn, the Earth rotates us around. As soon as we make that turn into darkness, we can see that moon in the sky. And we'll go ahead, and again, we're going to go ahead and take a quick photo and make sure I'm looking directly over the Earth, and I am, and I'm focused on my moon. Nope, wanted to focus. Come on. There we go. It's a little bit tricky. And as we keep going around, oh, what happens here? The moon should be gibbous. And if we take a picture here, did I get a gibbous moon? No, I had a blurry photo. In any case, as you go around and you continue to draw what you see, and you see that, oh, I'm starting to get a little bit thicker crescent. Here I get the moon is split completely in half. And what we notice is that each time the shaded part is getting smaller. So what we're actually seeing, if we think about the moon as a planet, is we are actually watching sunrise, the line of sunrise spreading across the moon from east to west, just as we would expect. If you think about it, if you think about a globe in your head and you think about viewing the Earth from a very distant place, we would see, of course, as the Earth spins, that line of light, that sunrise line, the terminator, sweeps from east toward the west. That's why it's sunrise on the east coast of the United States 3 hours earlier than the west coast. And we see that, oh, these things are happening. And so as we watch this, if we continue to work this, we're going to end up, and yes, I'm cheating again, we're going to end up with this lovely diagram, which shows us all the positions of the moon and all the phases. And we can take a look, Scott, we can find a map like this. We can find a model like this. We can find a drawing like this anywhere we want on the internet. You pull them up and you can find, oh, here's a diagram of the 8 phases, and we have 12 here, and that's okay.
Sure.
But the idea that, number one, there's not just 8 phases. The moon's phase changes continually. And if we take our model and we run it around here, I've always thought it would be fun to have a thin piece of like masonite or something and go ahead with a magnet and go from underneath and make it change. But if we go ahead and we move around here, we end up not only with a great drawing, if you're working in school to have the children make a diagram like this of lunar phases. Okay, go out tonight. Where are we? Are we in the part of the waxing phase? And in this phase, we're going to see the moon in the evening. Where in the waning phase, why do we see this waning crescent moon in the daylight? Because actually this waning last quarter phase, we start to see it at midnight, but it's also visible to us in the morning sky. As we are rotating, remember, we're rotating around on the Earth every 24 hours. So as we end up here, oh, we can see that moon in the morning sky. So waning moon is always visible at sunrise. Waxing moon is always visible at sunset. Okay, children, go out and look at the moon. What phase is it now? If you end up doing something like this at an outreach, and now it's getting dark, we've taken a half an hour and we've done this activity. Oh, there's the moon, everybody. What phase is it? Oh, I see. It's at night, so it's a crescent. It's a fat crescent. It has to be this one. Oh, good. What are we going to expect to see in a few days? Oh, I know. That's going to be the first quarter. Oh, why is it called quarter? Because the moon goes 1/4 of the way around its orbit to get from there to there.
Right.
And so now you have this model, and students can play with it. They can go ahead, oh, let's go ahead and assign dates when we see all of these. Oh, sometimes we have clouds, we're missing data. Yes, science is never perfect. We're also teaching that although the sky is our laboratory, we don't control it. Every scientist explores nature, but we don't control it, in spite of the fact that we talk about controlling variables in experiments. You know what, Scott? In astronomy, we often don't control the variables. We just have to observe what's there. And so this wonderful model shows us how the lunar phases work. And the amazing part is that I've had many young adults, children. Now I understand how it works. I said, oh, good. So you know the moon changes phase. How do you know? Well, oh, here we go. There's a planet and there's a moon, and the moon goes around and the sun is a single candle. And here, let me show you one of the most impressive things for a teacher is I say, okay, when you have parent night, set these things up and have your children teach your parents how the phases of the moon really work. And all of a sudden, the teacher is brilliant. Our daughter's teacher is so amazing. Oh my gosh. Did you really know that, Alice? Did you really know that, Johnny? Yes, we did. We knew that, and let me show you how. And it's very impressive, and it's very simple. And as important as all that, Scott, this is dirt cheap.
Right.
I have people who make these out of salt dough. Those of you who don't know salt dough, you can look up the recipe on the internet. You can make this much salt dough for about 6 cents, literally. It's 2 parts flour and 1 part salt, and you mush it together, and then you mold it and bake it in the oven.
You do need water, and if you're allergic to water, you might.
If you're allergic to water. Scott and I were talking about a story from when I was teaching. I had a parent tell me that her child was allergic to water, and watching ice cubes melt might have harmed her health, which was really very funny. And I'm just a science fiction writer and old teacher. I can't make this stuff up. But this is so inexpensive, Scott, that it's affordable to anyone, anywhere. It doesn't matter what your level of resources are. You can do this. I've had people say, oh, but I don't like spray paint. Okay, tempera paint. Oh, well, I don't want paint at all. My children can't have that. I said, okay. And one of my grad students came up with this. They said, why don't you take a potato and peel one of those little round red potatoes and peel half of it. Half of it's dark, half of it's light, and then, throw it in the pot and eat it for dinner. You're not wasting anything. You can do it with an orange. You could do it with salt dough. You can do it with ping pong balls. And next week, Scott, what we're going to do, and I'm hoping if you're doing this, if you're following along, you'll download the activity, download the book, download the activity from explorescientific.com/howdoyouknow. You'll find the activity there. You can also write to me at astronomyforeducators@gmail.com. I want you to make this model. And I want you to have a couple extra ping pong balls ready for next week, because next week, what we're going to do, Scott, is we're going to expand this model, and we're actually going to add a model. Sorry, out of the way here. We're going to add a model for Venus. And Scott, you know why it's only half black, half white with no features on it. Venus is all clouds. You can't see any features at all. And we're going to add an outer planet. I've chosen Mars. You can do Jupiter or Saturn if you like. And we're going to show you how you know the sun is in the center of the universe. Or in the center, sorry, not the universe. Pardon me, the center of our solar system. And everybody knows the story of Copernicus. Aristarchus of Samos said the sun is in the center, it's the only logical place. And Copernicus said, well, this solves so many mathematical problems. And Galileo fought with people from the Inquisition and all of this. And so the question is, we all teach the sun is the center of our solar system, but how do you know?
How do you know?
And next week, we're going to use these ping pong ball models, and we're going to add 2 more. We're going to add 3. We're going to add a little sun. We're going to add a Venus, and we're going to add a Mars. And we're going to show you what Galileo discovered. We're going to show you how you know that the sun is really in the center. Because in fact, if you set up this model, you'll find that the way Venus looks in the sky can only be explained by the sun in the center model. The other fun thing that I did just before we go, somebody asked me, well, how do you know the moon isn't flat? And so I made a model, because this actually comes from the time of Aristotle. And so I made a model with 3 poker chips that are epoxied together, and one's painted white and one's painted black. And I said, okay, set up this same thing before with the Earth in the center and the moon going around. Aristotle knew that. And try to make the phases appear with a moon that's flat and black on one side and white on the other. And I'll let our viewers try that. And of course, gee, surprise, it's not possible. So how do we know the moon is not flat? Because it exhibits phases, because we talked about last week about how the craters are elliptical. This is just another proof, and it's great when 2 scientific models that are very different, like our model with the, you can see it over my shoulder there, rubber ball with the strap with quarters on it. And here we have a flat moon model, and both of them confirm that the moon cannot be flat, it must be round. And with that, do we have any questions this week you'd like to pass along?
You know, I don't know if anybody can hear me. Can you hear me okay, Daniel?
I'm hearing you.
You're hearing me. Okay.
I'm hearing you.
The broadcast is not hearing me.
Okay. Well, I'll ask people, if you're watching the broadcast, if you have some questions, please send them in, because we can take a couple minutes and we can answer questions.
Okay.
And we're still fiddling with trying to see if I can see questions
Right.
or if Scott can see questions.
Yeah, just somebody wanted to buy one of those orreries, those expensive orreries out there in New.
Yeah, it's Orrey, I think, Orrery, and you can look them up on eBay or Amazon or Google. They are heinous. They started around $500 for a cheap one, and ones that actually have a light bulb in the middle for the sun and a little motor, they're like $1,500. I think you could finance a classroom full of ping pong ball models every year of your career for a century for less than that. These are 50 cents a piece. If you're buying your ping pong balls in bigger sets, this costs you 50 cents. Kids, bring in some Gatorade caps, kids, and you get a tube of construction adhesive that'll last you for many, many years.
Right.
And here you go.
You can't.
If you're making salt dough, this model literally costs pennies. And it's important, because the finances of your local school or the finances of your local club should never stop you from teaching good astronomy. And that's been kind of a crusade with me, is make this affordable so everyone can have access to it. STEM shouldn't be for the well-to-do. STEM should be for everyone. And part of the Astronomy for Educators program, and you'll see this in the book, and you can find Astronomy for Educators. There's links at Scott's Explore Scientific page. You can put in Astronomy for Educators, Daniel Barth, into any search engine. It'll pop right up. We have over 4,000 schools now. We were at 3,800 last week. We added 200 people this week.
Wow.
So I think we're close to 4,100 schools. We're close to plus 300, 250 certainly from last week. And that's the viewership of this program. And I hope everybody will download a copy of the book and tell your local teacher, tell your child's teacher about it, tell your club about it, and contact me, astronomyforeducators@gmail.com. And go see Scott's page at explorescientific.com/howdoyouknow, and all the fun stuff on Explore. Oh my gosh, so many toys, so little time.
Yes. Well, thank you very much. I know you guys can't hear me very well, but I want to thank Dr. Barth for appearing with us again. Watch him next Monday for episode number 3, and we will try to have his teaching curriculum up early so you can download it and follow along. So
I'll get you, I'll make sure, Scott and I will work to make sure that it's up. This is Monday. We'll try to get it up by the end of the week so everybody has plenty of time. So keep checking back. We'll get it up as soon as we can.
Okay. All right. Thank you. And tomorrow we have Global Star Party.
Excellent.
And so that will be starting at 8 p.m. It's our 38th Global Star Party, and it is celebrating the 1840, the first ever photographs of the moon by Draper. So we have some exciting guests coming up. It'll be a lot of fun.
I'll be there too.
Okay. That's going to be great. All right. Take care and keep looking up.
Thanks, everybody. Bye-bye.